Hi, this is Alex from devstories.eu. PySpark Fundamentals, Episode 11 of 21. When you are staring at billions of individual records, reading them row by row is impossible. To extract any actual meaning, you have to summarize them. Today, we cover exactly how that happens, the mechanics of grouping and aggregation. Under the hood, PySpark processes aggregations using a classic data strategy called split, apply, combine. This pattern is exactly what it sounds like. First, PySpark splits the massive dataset into distinct logical buckets based on a key you choose. Next, it applies a specific calculation to every single bucket independently across the cluster. Finally, it combines those independent answers back together into a single summarized result. In your code, you trigger the split phase by calling the groupBy method on your data frame. You simply provide the name of the column you want to use as your grouping key. For example, if you have a massive table of historical transactions, you might group by the username column. Here is the key insight. Calling groupBy does not return a new data frame. Instead, it returns a transitional construct called a grouped data object. Because PySpark evaluates your code lazily, it has only built the execution plan for organizing these buckets. It will not actually move any data until you tell it what mathematical operation to perform on those buckets. To provide that mathematical operation, you chain the aggregate method, typically written as agg, directly onto your grouped data. This handles the apply and combine phases. Inside the aggregate method, you tell PySpark what to calculate by using tools from the PySpark SQL Functions module. This module contains dozens of optimized aggregation operations. Let us say you want to calculate the average income for each of those users. You would import the average function, usually referred to as AVG. You pass the name of your income column into the average function, and you place that inside the aggregate method. When this executes, PySpark calculates the average income for every distinct user bucket simultaneously. The combine phase then kicks in, returning a standard readable data frame. This new data frame contains just one row per user paired with their newly calculated average income. At this point, you have a perfectly summarized table. However, because the calculation happened in parallel across a distributed cluster, the final rows are returned in whatever random order the processing nodes finish their work. If you need to see the highest earners, random order is useless. To fix this, you chain the orderBy method to the end of your aggregation step. You pass the orderBy method the column containing your new averages, and you tell it to sort in descending order. PySpark will take the combined results, rank them, and deliver a clean, sorted table. The split, apply, combine pattern is powerful precisely because it maps perfectly to distributed hardware, allowing massive datasets to be summarized in seconds. But remember that grouping data is only half the operation. Grouping requires an aggregation to finish the job. Otherwise, you just have a cluster full of empty buckets waiting for instructions. Thanks for spending a few minutes with me. Until next time, take it easy.